Danger. Interrupter PulseCloser fault interrupters operate at high voltage. Failure to observe these precautions will result in serious personal injury or death. Some of these precautions may differ from your company's operating procedures and rules. Where a discrepancy exists, follow your company's operating procedures and rules. This video is intended to be used in conjunction with the written instructions that came with your product, S&C Instruction Sheet 766-530. This video series covers protection and communication setup of an Interrupter PulseCloser fault interrupter by using IntelliLink Setup software. Before beginning, read and understand the overview section of the written instructions. You will need to be familiar with the unique features and functions of an Interrupter PulseCloser fault interrupter before continuing. In this video, we'll illustrate how the Interrupter PulseCloser fault interrupter can be used for intelligent fuse savings. The Intelligent Fuse Savings feature senses fault current levels and only allows fuse-saving operations when the current is low enough that the fault interruption can occur before the fuse blows. The Interrupter fault interrupter will not attempt fuse savings if the fault currents are high enough that the fuse cannot be saved. This eliminates the unnecessary momentary outages of high current faults. To configure the Fuse Savings feature, navigate to Setup, Protection, and select the general profile that will be used. Intelligent Fuse Savings can be used on Direction 1 current, Direction 2 current, or both. In this example, we will configure Direction 1 only. First, configure the initial trip settings per your protection requirements. See the previous video on General Profile Configuration. The initial trip configuration represents the fuse blowing curve in a fuse blowing system. This is the curve that coordinates with upstream fault interrupting devices or a substation circuit breaker and will allow the fuse to blow. Next, open the Initial Trip Additional Features drop-down menu. In the Intelligent Fuse Savings section, select the Phase and/or Ground checkboxes. Now click in the Inverse Segment box and select the best curve for your application. The Intelligent Fuse Savings curves are kept in the IFS TCC Curve XDT files folder. Inside that folder are curves based on different fuses. In this case, we'll use an 80K speed fuse. When the fault currents are low enough that the fuse can be saved, the Interrupter fault interrupter will operate on the 80K Intelligent Fuse Saving segment. When the fault currents are too high for the fuse to be saved, the Interrupter fault interrupter will operate on the initial trip curve or the fuse blowing curve. The last step is to configure the test sequence. Navigate to the Testing After Initial Trip page. When using Intelligent Fuse Savings, a point-on wave close is required somewhere in the IFS sequence to ensure that a permanent fault downstream of the fuse will blow the fuse. In this example, we have chosen the third test to do a point-on wave close, which will fully close the Interrupter fault interrupter and provide enough energy to blow the fuse. Note the overcurrent sequence does not require a point-on wave close. When the fault current is too high for fuse savings, the Interrupter fault interrupter automatically operates on the overcurrent sequence in the test sequence. When the fault currents are low enough for the fuse to be saved, the Interrupter fault interrupter then operates on the IFS sequence in the test sequence. This ensures that pulse closing technology can be used for every step of the test in the overcurrent sequence if the fault currents are sufficiently high to blow the fuse before the Interrupter fault interrupter can operate. With the curves and test sequences chosen, we have successfully configured Intelligent Fuse Savings. For more information, see our website at snc.com.